So what about the sparse pyro solver? What's going on with that? Well, the number one pro here is the fact that it's sparse. That means that it only works on active areas. So we talked about in the last video how you could have situations where the smoke is disjointed, where you have smoke in one area of your scene and another smoke in another area. And rather than sectioning off two bounding boxes or two separate simulations for those puffs of smoke, the nice thing about the sparse pyro solver is that it only works on active areas, and it dynamically figures out which areas it needs to work on. That's what makes this a lot faster than the traditional pyro solver, and a lot more convenient because you no longer have to do clustering. So that's a huge pro with the sparse pyro solver. Also, they've made a lot of stride towards improving the combustion model. Instead of having flame and temperature create burn, which then creates gas, which is divergence and more temperature, and rather than that whole mess, the only thing you do is you define a field called flame. And that flame determines where things blow up, and it's really as simple as that. It's a lot easier to control. It's a lot easier to learn and understand, and that's a major plus for the sparse pyro solver. Also, it offers the potential for detailed customization, just like the traditional solver does. So that's a really nice thing. You also don't need to worry about clustering, as I mentioned before. This will most likely be receiving new development in the future. And you also have the advection reflection options, plus physically accurate temperature buoyancy parameters, which is nice to have. Also, this allows you to add in a speed field without any manual setup. The traditional pyro solver can't say the same. And so that's a nice thing as well, because that speed field can be very useful when creating microsolvers and masking out those effects. Now, what about the cons? First of all, fast-moving objects can easily create artifacts caused by the adaptive container not keeping up. And so what you'll see with the sparse pyro solver is that sometimes that active field starts chipping away at blocks of density. And so if you ever notice this weird Minecraft-looking smoke happening, that's the best way I can describe it, this blocky smoke happening, that's probably because the sparse pyro solver is not adapting to the velocity quickly enough, and it's cutting into your sim. So you have to worry about that. And also, along with that, if that is happening, then you might need more sub-steps than the traditional solver for those situations. And in general, I've just heard people say that the sparse pyro solver requires more sub-steps, no matter what. So either you add more padding or more sub-steps, probably both, and that will get you a better result. But do know that out of the box here, this sparse pyro solver has a difficult time with fast-moving objects. Also, sourcing collisions and certain forces requires plugging into weird inputs along the solver. That's not a big deal if you know about it, but if you're new to Houdini or you're just not used to it, then you're not going to think to source collisions in the updated velocity inputs for the sparse pyro solver. And that's currently how that works. It doesn't give you errors if you plug it into the wrong place. There's just a few things that are a little bit strange about it at the moment. Also, OpenCL is currently not supported. That may change in the near future. And lastly, it does not feature dual rest fields by default, which is a major con because you now have to go create your own rest fields, and that's a big pain in the buns. So what does that mean with the sparse pyro solver? Well, it means that it's not a bad option. It's still a little bit green in the sense that there's a few weird workflow things that are happening, like with collisions not going into the sourcing section. But once you get over that, it's not too bad. And the dual rest fields is annoying as well. But if you have a pre-made setup that you copy and paste into new scenes, or you have an HDA, something like that, then you only need to figure the whole rest field thing out once, and then from there, then on out, you can just copy paste into new scenes. So I don't see those cons being too bad. The one major con that you really can't get over is the fact that the adaptivity is not going to keep up with fast-moving objects very well. But to be honest with you, the cons for the sparse Pyro solver aren't too bad. It's definitely worth that combustion upgrade. It's worth the fact that you don't need to use clustering anymore. It definitely beats out the traditional Pyro solver, in my opinion. The biggest limitation is going to be fast-moving objects, but you do have ways around that. The next Pyro solver we'll be talking about is the Axiom solver, which is developed by Matt Puchala. So this is not an official side effects Pyro solver. However, what Matt has done with this add-on is fantastic. And I'll give you a spoiler right now. This works better than anything side effects has done for Pyro in many different ways. And so with Axiom, let's talk about the pros and cons of that. So what makes Axiom so cool? And by the way, I just want to let you know, I'm not being paid by Matt or side effects or anybody. I'm just giving you guys my opinion on this, just so you know ahead of time, okay? So number one, this is faster than the native Houdini Pyro solver by a large margin. Sometimes Axiom performs 16 times faster than the native Houdini solvers do. And that's a pretty big speed bump right there. Also, it's very easy to use and learn. I picked it up in an afternoon, and it's pretty simple the way that the workflow happens. Also, this offers the least number of steps to getting your Pyro simulation up and running. And that's nice if you want to save time, which you always do. And you don't need to worry about clustering. So because of the fact that this is using VDB, there is a natural adaptivity to how this works. And, well, this has the sparse capability built into it. So if you had those two puffs of smoke like I've been talking about, you don't need to worry about clustering in that particular situation. So that's really good. This also integrates with Nano VDB, which is pretty sweet. It's a new technology that NVIDIA created for sourcing VDBs, and that will give you a speed bump. This uses your GPU, and this offers features that you won't natively find with the side effects Pyro solvers. As an example, you won't find axis-based control ramps, meaning that you can create effects based on, let's say, the smoke's height in the Y direction. Stuff like that, you really can't just find tools that do that within the Houdini Pyro solver. And lastly, it offers the best overall experience, in my opinion. So the Axiom solver is a joy to use, quite frankly. I think it's a fantastic add-on, one of the best plugins I've ever used. Now, what about the cons? Well, it's not free. So if you want to use Axiom, you have to pay for it. I think it's about $100 for an indie license, a bit more if you're not indie, but that's the deal there. And it does not allow for fully customized setups. So if you want to use verticals or you want to go in there and really change the way that things work, you cannot do that with the Axiom solver. And that is, in my opinion, a pretty big con. So what does that mean about Axiom? Well, I've thought about this pretty hard because it's a close call between using the sparse Pyro solver and using Axiom for this course. Now, because of the fact that I'm trying to expand your guys' knowledge of how to do custom setups, and this is a bit more of an advanced course, I think that the best route to go is with the sparse Pyro solver. I want to show you how you can add in verticals. I want to show you how you can go in there and tweak certain microsolvers to give interesting effects. And because we can't really do that with Axiom, I don't think that it would offer you guys the same educational value in this particular course. Now, if I was in production and I wanted to give a client something that was great, that didn't take much time, and was easy to use, then I would lean towards Axiom. And if you're a professional who uses this and you charge people a lot of money, it's totally worth the $100 or the $300 or whatever he's charging for this plugin, in my opinion. It's worth it. It's a good one. It's something that I think every professional who uses Pyro should seriously consider. So I want to insert a few more thoughts here. This is Tyler from the future now. I've grown out my mustache since that was all recorded. But okay, so Houdini 19 has come out, right? It still is, in my opinion, worth doing the Axiom versus the sparse analogy. That's really the two main options you have. Now, what about the SOP level Pyro solver? What's going on there? Well, as of Houdini 19, that solver has been completely redone. You have the option of doing the traditional setup, the sparse setup, or you can do a really fast GPU setup with that SOP level Pyro solver. We're not going to be getting into that Pyro solver because in order to understand that, you'll need to understand how to build setups manually anyways. It's a much better way of learning that way. And at the end of this course, if you play around with the SOP level Pyro solver just for a few minutes, you'll know exactly what everything is talking about. So for that reason, I'm not going to be teaching it in this course. In practice, in production, I think that the SOP level Pyro solver is much better than it used to be. I think it's much more viable. I would personally use that in a situation where I didn't have the Axiom solver available to me, and I wanted to put out something that's really quick, something on a tight deadline, something where I can't mess around with the intricacies that I normally would if I was trying to build everything from scratch. Another option to consider is that you can always just build out your custom Pyro setup with all the fun features that you like to have, maybe with the vorticles, maybe with all sorts of techniques that I'll show you in this course. And then you can just copy and paste your own Pyro solver or your own setup into whatever project you're working on in the future. And so there's nothing to say that you can't take bits and pieces of what you learn along the way and then just use your own HDA for that. I know that's probably what most professionals use if they're freelancing. So anyway, it just all goes to say that Side Effects has done the SOP level HDA thing for you to some extent, but it still is not going to have a lot of the features that you might like, such as utilizing vorticles as an example. And so my advice is to generally stay away from the SOP solver and build out something on your own that achieves a similar purpose. Or again, just use Axiom if you can afford it. So for this course, what are we going to do? We're going to use both the Axiom and the sparse Pyro solver. In my ideal workflow, if I have something that I need to crank out really fast, then that's a great situation for Axiom. If I have something that needs to be really custom and I need to go in there and adjust all kinds of different features and get really specific and technical with it, that's a better situation for the sparse Pyro solver. So between those two solvers, we're going to layer on multiple Pyro effects, multiple elements to give us the full effect that we're after. In the next video, let's move on to sourcing density.